how do I design parts for 3D printing? Well, if you're not sure, you're in luck. You don't need to be an engineer to design anything. There are a lot of different options. Most people start by downloading models that others have made from popular design libraries. These design libraries have millions of designs like Makerworld or printables, and you can just search for whatever you like. If you can't find the design you need, of course, you'll need to make your own. Then what do? Well, if you're not sure where to begin, start with the free suite of design tools by Bamboo Studio in their Maker Lab section. Here, you can find a bunch of design tools that help you design specific things. They're really super easy to use. This one here makes a design from any image. This one here makes a design of any video of an object. And this one here makes a lightbox design from any image. And there are many, many others. They're free to use, so go check them out. Next, you can even modify your design in the slicing software. Continuing on with Bamboo Studio, you can split a model into parts, you can color the model, you can add holes and negative parts, you can join models together, you could add text, you can change the size, you can use graphic files, and a whole lot more. Next is using AI design. You can describe what you want and get a model extremely quickly now. You can even upload photos and get a model. This is a total game changer, allowing much larger accessibility to design and making than ever before. Next, any parts that need to be very accurate and well-defined by simple lines and curves can be designed using a parametric design software like Onshape or Fusion 360. These softwares work by drawing a 2D sketch and then converting it into a 3D object using a feature. If, however, your part is not so accurate and not well-defined by simple lines and curves, you should opt for a more sculptural approach. Sculpting design software is what we should be looking at here. Softwares like Blender and Nomad Sculpt basically start with a digital ball of clay, and then you push and pull it until you create your model. These are a lot harder to use, so I wouldn't start here. And finally, 3D scanning. You can use a handheld 3D scanner to accurately capture a part or an environment to place in 3D design softwares. This is super useful for recreating parts or measuring an environment that your part will fit into.
I get this question a lot. Like, how do I design parts for 3D printing? I get that question like all the time, like at least a few times a week, right? And in reality, it's always going to come down to what you want to design. And there's a different path depending on what you want to make. So one of those paths that you saw is parametric design, right? So I'm going to show you how to make parts that have well-defined geometries. And this could be like anything from like car parts to hinges to enclosures to brackets that hold your bike and bike accessories. So let's jump into what is parametric design. Where the word comes from is actually parameters. So parametric design, we're designing with parameters or designing with variables. So if I'm making an enclosure, the variables might be the height, width, and depth of the box, the thickness of the box. The true power of parametric design is that we can design with these variables and then we can update them accordingly. So if I print out this enclosure and the height's wrong, I can go and easily change that. If you start with an STL and use sculpting, you can't easily change those things. So the parts have well-defined geometries. And what that means is that they can be designed from simple lines and curves, okay? So if I'm looking at this car part, this is like a spherical piece with like a long kind of neck, but that has a consistent curve around its axis. Then it's got these mounting holes that you can see right here. And those are circular cutouts that like go to a specific depth, right? And they have a specific diameter, right? When we're designing stuff like this, we use parametric design. The advantage of this is that you can do really simple parts like this or much more complicated systems, but the foundational knowledge, what I'm going to show you today, that is used in either case. It's used for making one part and it's used for making assemblies that have thousands of parts, right? I've designed machines that have thousands of parts. It's not as complicated as you would think. It comes down to very simple things and you just repeat that process over and over again. So over time, it looks complicated, right? But really, everything in this system, if you pull it apart, it's like a circle or a line or a simple curve. Obviously, designing it to run a ship into space is a little harder, but the actual shape of it, not that hard to make. So how does parametric design work? How do you actually go through and design a part? So 3 easy steps, right? Number 1, creating a sketch. This is a 2D drawing that we draw on a flat plane in our software, okay? So it's literally like, I've got my pen and paper and I'm drawing that sketch onto it, right? How many of you here could draw this shape? There's a circle, some other circles. It's not too difficult, right? So everyone here will be able to draw this, right? Then number 2 is you apply a feature. So you've drawn your sketch, That's the flat 2D image, right? Then you create a feature, and that brings it from the 2D space, usually, or most of the features bring it from the 2D space to the 3D space. Okay, so we're going from a sketch to a 3D object, right? And there's different features that you can apply there. I'll go through them in a minute. And then you just repeat that over and over again to get different features, to get different elements on your part. Okay, so its sketch is in 2D. Then you put a feature which makes it into 3D, and then you repeat that process over and over again to give your part more complexity. That is literally the process that everyone uses in parametric design. That's the foundational steps that we take to build all sorts of systems, right? And then I mentioned sketches and features, right? The actual sketches themselves are comprised of different elements. It's actually quite basic. I've drawn a circle here, right? I've drawn a square, right? And then I've drawn an arc and then a polyline, okay? So a polyline is just like a curve, right? And those basic sketch tools that I just mentioned, line, curve, an arc, that's it. Like, you don't get a lot more than that in these softwares. Seriously, to describe basically all these shapes that you can design, that is pretty much what you get. Now, what's the disadvantage of this? Well, if I wanted to design my face, for example, like a sculpture of my face, it would be really hard for me to draw the exact lines and curves to describe my face using these tools. So I wouldn't do that in a parametric design software. I would do that in a sculpting software like Blender or Nomad Sculpt or something like that. So that is literally it. Like, you have lines, curves, and then you apply features to them, right? So on the left here, this cylinder, it is just taking the sketch, the circle, and making it go straight up into space. Or you can pick a different direction, but it's just going to sweep it straight through space. It's called an extrude feature. So I literally drew the circle, hit extrude, and then that creates that cylinder, okay? This other one here, it takes the rectangle and it revolves it around this point here where my mouse is. It just rotates it. That's what revolve means. And I've just made it rotate around 45 degrees, so it creates a wedge. And then this last one here, I've taken my kind of weird shape on the right, and what I've done is I've swept it through space. Okay, so I actually made this go left and then right and swept that design through space to create my 3D model. That's called a sweep feature. So I've got extrude, revolve, and sweep here. Okay. And literally, you can basically do everything with those features. There's other features, of course. There's actually a lot more features, right? And some of them will make your life easier when you're designing things, but you basically can design everything with these 3 key features. Now you can see this in 3D. So I've actually created a 3D model here. I've actually embedded that into my PowerPoint slides here. You can embed 3D models into your PowerPoint, which is cool. I think you can even embed GLB models into PowerPoints, which means, say if this was a product, I could actually have colors that could look like the product, and then I could embed it into here and show a client or something if I was trying to sell it to them or whatever. That is how easy it is to go from sketch to features. What makes it complicated, what makes it look complicated, say that rocket engine, is you're just repeating that process and you're putting pieces together. And in these softwares, you have the ability to put pieces together and build it without actually building it, right? And that's what assembling is doing. It's allowing you to put those parts together and actually see how they would interact before you go and build the thing. Why would you do that, right? Where these softwares kind of came from was helping engineers. You wouldn't want to build the system and then realize, oh, this part doesn't fit because there's no clearance here. So you can kind of test your assembly before you actually go and build it. Let me show you Onshape. This is an extruder that melts glass, but it's going to be handheld. There's this heated block system that is here that has this coil, an electrical coil that will basically heat up this nozzle. I was like, oh, let me go and design this, right? So the typical workflow that I would go through is you have an idea and then draw it down first, right? And I drew it down and I thought, yep, parametric design is obviously the choice here to design these parts because they're really well defined. The holes are very accurate. They need to be in the right position and all that kind of stuff. So I did that. And then you might be looking at this going, wow, I'll never be able to design that. Now, let me just show you how easy it is to actually make this part, right? So I've shown you the whole thing there, right? So let me go here. And what I've done here is I've rolled all of this back. And you can see here, I've got sketches and then a revolve, another sketch, a revolve. And what I've done is I've hidden all of these ones. So they're not actually loading now because I've moved this roll back bar. I'm going to show you how I built this step by step, right? I did this sketch. So I went into it. I drew this sketch. Could you draw a rectangle with a little shape at the end here? Probably yes. And then all I did, I literally clicked one button called revolve. That's the revolve button right there. And it took that sketch, rotated it around like that, and then it made a 3D object. Wow. So challenging. Then I did another sketch. Oh my goodness, I drew a rectangle. Then I hit revolve. All right, and that's the ceramic sleeve that goes around it. And then I named it ceramic tube because I knew I was going to have a lot of parts to this. So I actually started naming them. You see here, if I hide that revolve, the tube's gone from this parts list. I've only got the nozzle there. And then once I go to revolve, the ceramic tube comes up. So I literally just repeat this process over and over again. If you're an expert or if you've got a passion in a field and you know like you could create something with value, then it's just you trying to get that onto paper or onto the screen, right? And where you would start again is you start by drawing it, right? You draw it down on a piece of paper and then you come into here and then you try and create it from these basic sketches. So that is the process repeated over and over again. And then once I'm happy with that, I've made the part, but I might want to actually 3D print the nozzle just to feel how big it is. Maybe I want to put the temperature sensor in there and like check that works. All I have to do literally is once I've made this part is click it, right click on the part, export STL, boom, STL. That's it. And then that's my nozzle. That's the name. I click download and then I can like literally open that and then go and print it. And if you don't know how to do it, here's the beauty of it. You just ask me in the school community, right? So literally just go into here, and you write something, you say, design question. Hi, I'm trying to design XYZ. I'm using Onshape. I'm not sure. Help. And then you'll get help, okay? What I'll probably end up doing is making you like a video reply, okay? Or something like that, or at least walking you through the process. Once I print that in physical space, I might want to go back and change things, right? And that is the cool thing about parametric design. Say I want to make a change, I can go to my part, I can make a change to the sketch that actually made that. See this sketch here that made the top bit. So I can make it, that needs to be thinner, right? So I've just made that update and then go, okay. And then look, now it's like a bit smaller. See that? I really encourage anyone that wants to design to give it a go. Any questions? Does Onshape allow variables like fusion parameters? Yes, 100%. It's right here. It's called variable. So let's say I go back right at the start and I'm going to put a variable right at the top here called length. And I said, I don't know, 50 millimeters. Boom. Then if I go into my first sketch, I haven't actually added dimensions here. So if I want to know how big it is, I can click on that. So what I did is click D on the keyboard, but you can click dimension here and dimension it. So now I can use that. I could just type in 50 millimeters, right? But I've made a variable. So what I can type in is length. And let's see how it automatically found that variable. And I can click that and click OK, and then click OK. And now if I create my feature there, so I've got my extrude, I've made that visible. But if I could change my length to 100, I don't have to find that sketch. It just automatically updates it. See that? So what you can do is you add all of these variables, the ones that really matter to you, that you would want to maybe tweak and make different versions of your part. Another thing that you can do, circular patterns. So I could say, I want to pattern this around this circle. See that? And now I could go, I want there to actually be 30 instances. And see now I've got like this crazy thing. I'm going to go add, so I can add them all together, right? And now I've created like a gear kind of thing. I don't know, like a weird kind of shape. That's a circular pattern. There's actually all these features that you can see here. A really popular one that is cool for 3D printing is the shell command. See how it's shelled it out? So for 3D printing, it's good if you're doing big parts, especially if you're doing vases and stuff like that, you might want to shell it out. I mean, that's a whole other thing, right? Like how do you design for 3D printing? Like actually, when I recommend to design vases, I recommend to design it completely solid and then print just the outer loops, like 3 or 4 or 5 outer loops. That actually prints it way faster and much more cleaner flow. Whereas when you shell it like this, let's do it right now. So I go, once you download it, you can actually just drag it into Bamboo Studio. Boom. All right, so say I've got that, it's shelled out. And I go into my walls here and I see how it actually prints. See here how it does the infill and it's got to like start and stop, right? That takes a lot more travel time. If it just swept around that path, then it would be much easier. So what I would recommend then is to go back into here, get rid of that shell command, right? Re-export it, no shell. I'm going to open up another plate and then I'm going to go and drag it in there. Boom. And then instead of having like infill, I might just have 3 or 4 wall loops, no infill, and then no top layers, top shell layers. Boom, get that away. But now see how my shells, boom, boom, boom. It's like a race car just flying around this thing, right? So that's 3.5 hours. I wonder how much the other one took. It might be comparable. Depends on the thickness and the infill. 5.5. So I saved 2 hours by just going, hey, maybe I could do this a better way. And that's where the whole like, yes, you can learn to design, but you need to learn to design for 3D printing. So how easy it is to get started with this. Onshape is what we recommend. for parametric design. And the reason is because you can make a free account on Onshape for non-commercial use, and it's cloud-based, which means you just create an account online and then you can log in. It's kind of like Google Docs for parametric design. So that's just the first thing. Just practice that drawing, try to extrude it, try to revolve it, and actually make a 3D object, right? If you want to actually start learning this in a more formal way, you can do that a few different ways. So first is there's free learning that Onshape provides. So you can head to learn.onshape.com. Keep in mind that it's obviously not specific to 3D printing. People use design for a whole range of things, and they're not going to show you exactly what you might need for, say, for 3D printing. So obviously it's not outcome driven. What we've done is we've created a course for it. There's over 4 hours of video here that I've put into this. And basically we go through each of these sections of how to sketch, how to create features, how to assemble parts, and then what you need to do to actually 3D print these parts as well. So understanding slicing and printing, overhangs and stuff like that. To actually view it, you can check it out at 3dprintergear.com.au/courses. So just find the design for 3D printing course there. It includes 4 60-minute live sessions. So we'll actually introduce design to you, how to actually implement it in your project, and then give you live feedback from that.